discussed about amplifier, and that is also a single stage amplifier. That is, if we apply input at the input side of the amplifier, then we will get output at the output port. This is what we have discussed about amplifier, and we have seen different parameters regarding their voltage gain and impedances, gains, etc. Now we are going to discuss about stages of an amplifier. That is, if we are applying a small signal at the input of the amplifier, we have applied a small signal which is of very little volts, and we want to drive a load of which requires heavy voltage, and we have to add this extra amount of energy in this to drive the load which requires this much energy. To make this, we have invented amplifiers. So in this, if we give input at the signal which is very less voltage, and if the amplifier will amplifies it, and it will give somewhat amplified signal at the output. So if the voltage given by the amplifier, the signal which is amplified in that amplifier, if it is not sufficient to drive a load of this much, requires this much energy, then what we have to do? To change that problem, we are introducing multi-stage amplifiers. That is, more than two stages amplifiers, or more than one, that is 2 or more than 2 stages of amplifiers are cascaded in a way to bring more gain, to achieve more gain. That is what multi-stage amplifier is. In that multi-stage amplifier, we are cascading more than one amplifier to get large output. Given by a single stage amplifier, gain given by a single stage amplifier is not sufficient for some applications. If we want to drive a load which is a buzzer, or which is a large motor, or which is a have to drive a high loads, heavy loads, then the amplifier which is used in a single manner is not sufficient. So to change that, we are applying more multi-stage amplifier application there. Multi-stage will give required gain to drive the large loads. So this is what we are using multi-stage amplifiers. 2 or more amplifiers that are cascaded, that is, the output of first stage is given as the input of second stage. This is what cascading means. So the gain will be multiplied when their stages are increased. This is what we are doing in multi-stage. So we can achieve more times of gain, much gain, when we are going for multi-stage amplifiers. The multi-stage is achieved by coupling output of first stage to second stage, and so on. So we are cascading. If it is two stage amplifier, then 2 amplifiers are required. If it is more, then we have to add another amplifier here, and so on. And some to couple these two, we can't directly connect one stage to another. So if it does, for some applications it is not manageable. If it is beyond frequency, if because we are applying a signal, if the frequencies are changed, then the cascading will give, multi-stage will give a adverse effects. So to keeping this in mind, we are introducing a special concept called coupling. We will discuss it later. So some popular coupling devices are, so we are introducing a coupling device here in the middle of 2 stages, and the output of one stage will be cascaded to another stage and through these coupling devices. Some popular couplings are RC coupling. Name of the coupling is RC coupling, and the multistage amplifier name is RC coupled multistage amplifier. So if we use R and C, then we will call it as RC coupled multistage amplifier. And if it is transforming coupling, if the transformer is used in this place of coupling device, then it is transformer coupled multistage amplifier. If it is direct coupling, so if we do not use any coupling devices here, if it is direct coupled, and then we are calling that as direct coupled amplifier. Why we are using direct coupled? It is because we will discuss it later. And why? Because is mainly is if we the frequency range of operation based on that we are using different couplings. So direct coupling is for low frequencies, and we will see it later. And now we have seen about coupling devices and their use in. So what are coupling devices? Finally, what are coupling devices? Coupling devices are nothing but which will couple the output of one stage to input of another stage, that is its next stage. To couple these two signals, that is from the output of one stage to input of another stage, to couple this signal, the actual data, to couple those things, we require coupling devices. These coupling devices are of different types, that is RC, transformer and direct coupling, and based on this the amplifier is named in a different way. We have seen that. So these coupling devices are required to couple the signal from one stage to another stage. And why these are required? Because the advantages of this is to transfer the AC output of one stage to another, that is to transfer the only AC signal which is amplified in this at this output, which is the output that is generated at this stage, is only that output is transferred to this stage. That output has to be transferred to second stage. For that accurate purpose, we require coupling devices and to block DC interference from one stage to another stage. So we will use some DC biasing at the different stage, at every stage of the amplifiers, and these are multi-stages. So the DC biasing voltage of the first stage may affect the second stage, or the second stage may affect the first stage, or this effects will produce an adverse effects in the amplification of the original signal, which is required to block the DC interference, which will gives a good output. To make that, we require these coupling devices and to eliminate loading effect. So that means exact power matching and exact transfer of total output and to match the impedance. So for those things we require these coupling devices. And RC coupling, in the RC coupling, capacitor and resistor are used. These two are aligned in a manner to make the RC coupling circuit, and in transformer coupling only a single transformer is used at the coupling device, and with the help of this transformer the coupling is done. In the direct coupling amplifier, no devices are used, only direct conductor is used to transfer the amount of energy that is produced at the output of the first stage to transfer it to second stage. So based on the frequencies we will use these coupling methods. This is all about coupling device and their uses. Now we have to learn some definitions which are actually required to understand, classify the different couplings or different coupling circuits. The first one is gain. What is gain? Gain is nothing but the ratio of output to the input of any electrical quantity is called gain. That is, if it is voltage, then V out by V in. V out by V in is voltage gain. I out by I in, then it is current gain. That is what we know that gain. That means output and input electrical quantities ratios are called gain. And what is decibel? We know that gain is expressed in decibels. So gain has no units because it is a ratio, and to represent the gain we are using decibels. So decibel is nothing but the 10 times of a common logarithm of base 10. Bell, common logarithm with a base 10 is bell, and 10 times of bell is called decibel. That is what decibel means. And the gain that is expressed in decibels is power gain is 10 into log P out by P in to the base 10. This is power gain, which is, if we want to express the power gain in decibels. Current gain is 20 log I out by I in. This is what current gain. And voltage gain is 20 log V out by V in. This is a voltage gain in decibels. These are all the formulas. And the bandwidth. And the next one is bandwidth. Bandwidth is the nothing but range of frequencies between 2 point frequencies, that is lower cutoff frequency and higher cutoff frequency. Between these two, the range of frequencies in between these 2 points, that is called lower point and upper point. The between frequencies are called bandwidth. So in the amplification point of view, the bandwidth is the range of frequencies over which the gain of the gain is equal or greater than 70.7% of maximum gain is called bandwidth. That is 0.707 of GM. That is nothing but GM is maximum gain. That is, at the frequency, at the 0 frequency, gain is low, and after going to some frequency, gain is increased. After going to some frequency, gain is again decreased, and after some frequency, gain is came to again 0. The F1 and F2 are the two cutoff frequencies. These are cutoff frequencies because the gain is 0.707 from this point, that is from the 0.707.2 of GM. The frequencies which has a gain, that is F1 and F2, the frequency range between these two are having a gain of more than 0.707 of maximum GM. So these frequencies are considered as a bandwidth of an amplifier. It must be greater than or equal to 0.70 times of GM, that is the maximum gain. This is what bandwidth. And the curve which is drawn in this manner is called frequency response of that amplifier. That is, it is drawn between frequency and gain. So the axis, the graph which is drawn between frequency and gain is called frequency response of an amplifier. The frequency range of operation of the amplifier is taken in this way, and the gain at the different frequencies is taken in this way. So these two, the amplifier which has responded in which way for the particular gain is considered as a frequency response of an amplifier. So these are the definitions we have to keep in mind.